Yo, 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 yo. Okay, cool. Cool, cool, cool. We're live. My name is Menace. It's short for Menace Katlunga. And I'm just a depressed CS grad studying at Georgia Tech. Uh, trying to get a job. Cool. In this stream, we're gonna again go through some more lead code questions, and then we'll also do some ML coding. Uh, and yeah, in in between, we'll also waste a lot of time, do random ass bullshit, go through some degenerate subreddits, so on and so forth. Cool. Uh, let's perhaps start with again. I've probably solved a lot more of these than the tracker shows. It's just that I need to update these. But anyways, let's see. How many do I need to do with bit manipulation? I need to do like, okay, reversing an integer, sum of two integers. That's okay. Math and geometry +1 rotate image. This looks cool, to be honest. Spiral matrix, set matrix zeros. I've done most of these. Power xn multiply strings to text square. Okay, anyway, I've done these. Insert. Let's sort by difficulty. Insert interval meeting rooms. That's fine. We all have like greedy questions. Okay, let's do maybe DP, and we haven't touched backtracking. I think I've done a bunch of these. Yeah, it's solved. Let's see. Is there really unsolved one? Combination sum I've definitely solved. Permutations I've solved, I believe. See, these are all basic backtracking questions, subsets too. I think I've solved this one too. I solved most of these, but perhaps like combination sum too. I think I've solved this one as well. Yeah, everything is solved. Word search, it used to be one of my favorites, not gonna lie. Yeah, solved everything, not gonna lie. Let's is there anything? Permutations is fine, subsets 2 is fine, combination sum is fine, combination sums 2 is fine. These are already solved then, huh? I think I've done task scheduler also. Binary search, Coco eating bananas. I don't know if I've solved this ever. Yeah, this doesn't seem like I've solved this. So let's see. Coco loves to eat bananas. There are n piles of bananas. The ith pile has pile I bananas. The guards have gone and will come back in HR school. Coco can decide her bananas per hour eating speed of K. Okay. Each hour she chooses some pile of bananas and eats K bananas from that pile. Okay, so bananas per hour speed of K, that's how many bananas she can eat every hour, and the guards will be away for H hours. So, okay, so it's gonna be like different Ks for every hour in H. Okay, if the pile has less than K bananas, she eats all of them instead and will not eat any more bananas during that hour. Okay, so that's nice. Coco got some, like, she's got some control over her appetite, I guess, like delayed gratification and shit. Okay, Coco likes to eat slowly but still wants to finish eating all bananas before the guards return. Okay. Return the minimum integer k such that she can eat all bananas within h hours. Ooh, okay, this is an interesting question. So we have piles, these are piles, and we know the ith pile has I bananas. Sorry, the ith pile has pile I bananas, makes sense. So the zeroth pile has 3 bananas, the first pile has 6, and so on. Cool. Okay. And the guards are not gonna be around for 8 hours, I guess. Okay, cool. So what does this even mean, right? So for the first hour, so it says that the K is 4. So for the first hour, she eats, uh, I guess, all 3 bananas. The second hour, she eats 6 bananas, and third hour, she eats the remaining two. The fourth hour, she eats 4 bananas. The fifth hour, she eats the 3 remaining bananas. Uh, the sixth hour, she eats 4 bananas again. Seventh hour, she eats 4 more bananas, and then 3 more remain. So in the 11th hour, sorry, in the 8th hour, she eats the last 3 bananas. Is that how they're doing it? Okay. This one says the guards are gone for like 5 hours, so uh, the banana eating rate needs to be 30 so that every day she can eat however many bananas she wants to eat. Then there is 6 where she can just do 23. This is okay, this makes sense, I guess. So here's the question now. Here's the question. Why is it that why does this question even fall under binary search, right? It comes under binary search. Let's see the constraints. There will be at least one pile and 10 to the power 4 piles, otherwise uh, okay, this is interesting. So the pile length will at least be equal to, hold on, the pile start length, okay, the hours can be at least equal to the length of the pile. Okay, makes sense. So if the r is at least equal to the length of the pile, then you know for sure that you can always have the largest r, the largest pile as your k, so that every passing r you need to finish one pile. That makes sense. And otherwise you have this much, cool, and you have a pile can have at least one or at most 10 to the power 9 of these bananas. Cool, cool, makes sense. So let's see. I'm just gonna write down my strategy here. Strategy, right? So it says it needs to be in a binary search. It says that it's a binary search problem, right? And I do know that none of my piles are sorted, right? Do I need the piles to be in the order that they were given? I don't think so, right? Like I can just, every pile is going to be consumed independently every hour, right? So I don't need the piles to be sorted, I guess. I'm just wondering, what if I do sort them? Like, what if I do sort this pile? Then it will be 4, 11, 23, 30, 4, 11, 20, 23, and 30. Okay. And then there will be 30, 11. Okay. Same goes with this one. You got 23. That's okay, I guess. That's okay. Cool. So, okay, Coco likes to eat slowly. What would my strategy look like? So if I want to do a binary search, it is important that I sort of do I do know that binary search happens on like sorted uh, lists or sorted arrays. So would sorting help in any way? Okay, hold on. Even before that, right? Let's write some base cases. Maybe we can get some pattern out of this. I know that if my length of piles equal say h, right, this is gonna be the minimum, then my answer is in fact max of piles, because uh, if every hour I must finish my piles, right? Like every hour I must finish my piles, and that is that, right? So now similarly, if I have any pile that is like for example, if I look at the first pile, so h can never be less than the pile length, h can always be greater than the pile length, right? So for example, now if I have a pile length of 4, which is 3, 6, 7, and 11, oopsie, and I have a total of 8 hours, then if I were, okay, if I had like 4 hours, then my answer would have been 11, right? But now that I have 8 hours, that essentially means that I get double the time. So I can do 11 and it'll still be done in 4 hours, but I need to do it in just 8 hours, right? Here's the question. What if I do the sum of all of these, like 6 plus 7 plus 3 plus 11 would be like say 27, and say I do 27 by 8, that would be like 3.75, I guess. That'll be like 3.75. So every hour I should be consuming at least 3.75 uh, bananas, right? That's what I feel I should be doing, right? And what if I do the same? Okay, 3.75, right? Like, what if I say that if I need to do, I know the 3.75 bananas can't happen, and I know that I cannot do a minimum of 3.575 bananas. So if I do like a ceiling of this, if I round this up, it'll essentially be 4 bananas. I at least need to do 4. Now let's say what if I do 30, or what if I do a sum of 30 plus say 11 plus say 23 plus 4 plus 20, that's 88, and say I do all of this, say I do 88 by 5, then it comes out to be like 17.6, I guess. So like I need to eat 17.6 bananas every hour at least, right? I need to eat 17.6 bananas every hour at least. Okay, so I know that I could eat 17.6 bananas every hour, but the problem with this is that uh, okay, so the problem with this is that Coco cannot ever eat bananas that are smaller, I guess, than. Okay, so Coco can never eat bananas that are going to be okay, so if my K were to be 17.6 or say 18, it would have made sense if there was a minimum of, if all bananas were less than 17 or 18, but there isn't, right? Like Coco is okay with leaving some bananas, but Coco is not okay with okay, so Coco is okay with eating all bananas even if they are less than her appetite, but Coco is not okay with leaving some bananas. So in her case, she cannot leave some banana. So I cannot do 18. So what does that tell me? What does that tell me? So I know that the sum of this is gonna give me 18. Like on an average, my K, the optimal K should have been 18. Uh, if I were to say like, okay, I want to place 18 in this thing somewhere, right? Okay, what happens if I divide this by 6? It becomes like 14 or 15. So if I had 6 hours, then I'd want to do it in like 15. My rate would have been 15 ideally, right? Now, if my rate was 15, what do I do with this rate? like ideally I know that my rate should be 15, but I know that I the minimum amount of, hold on, so if my k is 3, right, 23 for example. Oh, okay. So, okay. The Coco is okay with doing that. Okay, Coco is okay with eating fewer bananas and just going about life. I was wrong about that. So, in k equals 5, say we had 18 as our number, then in the first hour, Coco could have eaten like 18 bananas from the first pile. In the second pile, it would have obviously wasted her time, I guess, right? That would do no good to anyone. So that's pretty bad, I guess. 30. Okay, let's see. Let's see if there is anything in the discussion. Uh, yeah. No, screw this. Okay, there's something interesting. K equals 1. This is an interesting way. So 3 by 2, 6 by 2, 7 by 2, 15 greater than 8. So yeah, this makes sense to be honest. I get it. Okay, fine. So I know that the Okay, so if it's like a binary search problem and the search is not concerned with the order of the bananas here, then perhaps the search is concerned with the value of k, because that's what the discussions kind of hints at. And this is actually a pretty good thing to keep in mind, that that you will not just have to search based on the piles, but perhaps you are actually just brute forcing k. I thought of brute forcing it, but I just uh, try to look for the best answer at the first place. This is actually pretty cool. So we could just brute force and go through different values of k, I guess. Okay, cool. So what is the minimum value of k that we could pick, right? The minimum value of k is gonna be, okay, there's got to be an upper bound for k, right? The upper bound for k is gonna be like the max value inside the piles, right? If I get 30, for example, then I can just finish it in less than whatever 6 hours, because I just need to like finish it in just 5 hours, I guess, right? So max value agar 11 ho, to that's gonna be my yeah, that's gonna be my upper bound, I guess, for k. The lower bound for k, I need to figure out what's going to be the lower bound for k. So let's see. Let's write it here. K upper is going to be max of piles. K lower, how do we figure out the lower bound of k? Oh, that's exactly what we were trying to find, right? Like, I know we were trying to find the lower bound of k, but what is like a sensible lower bound? Like, can I always start with 1? Is that something that I could do maybe? Huh. Could do that, right? I could do just k equals 1, right? Because there would be cases where k is in fact 1 and just eating one banana every hour, right? And then how do you figure out if your lower needs to go above or upper needs to go below, right? Let's see. If I go here, 3 by 5 plus 6 by 5 plus 7 by 5 plus 11 by 5, bro. Okay. Okay. Okay, hold on. So a pretty good one, I guess. Lead coders, what? They're putting the irrelevant things, man. Oh, there's a mathematical way. Oh my god, people are trying to solve this for 3 days. Oh, I knew the starting end required. Pretty good, pretty good. Okay, given a fixed speed, K needs to check if cocaine banana and HRs recurs by setting K equals. Okay, I get it. Kinda get it. Kinda get it. Cool. I kinda get it, brother. So let's try this, right? Let's try okay, I'm just gonna do K. Okay, just gonna do low, high equals 1 and max of piles, I guess. This is how we're gonna try to do it, right? So low is gonna be 1, max is gonna be just max of piles, and I'm gonna be like while low is less than high. This is gonna be how our binary search algorithm works. And what we gotta do is h low. So r's of low is gonna be a so h of low is gonna be equal to let's just say sum of p by low for p in piles, for p in piles, and we'll get two values of h, right? We'll get two values of h, and suppose I do right, if I do like 3 plus 6 plus 7, that would be 25, right? Oh, sorry, that will be 27, my bad. So that will be 27, and if I do 27 by 11, it will be 2.4. So I know 27 is greater than, um, yeah, but this ain't binary search. This is like a window type of thing, right? Okay, so we don't need to do the check for both of them, right? We just need to do mid. Mid equals, of course, low plus high by 2. Let's see, let's do that. And h mid equals mid, right? So let's just see for example, right, if h mid, right, Let's try it with this one, for example, right? Uh, okay. Just give me 1 second. Five. Like, so if I do like a ceiling of this function, like if I do like a math.ceil, or if I just do int of 5.866 maybe, that would just give me 5, I guess, right? And could do a ceil, I could do just a 5, but what does that tell me though? What does that tell me? No, it does not. It just says that it's greater than. If it's greater than that, then it essentially means that I need to up my R's, I guess, right? And if it's less than that, it essentially means that I need to halve my R's, I guess. So it then becomes like 30 plus 15 by 2, which is like 22 maybe. And then it essentially becomes like by 22, I guess, and then it's like 4 or something, right? And this is also less than that, so it essentially becomes right. So earlier it was जो भी mid था, mid was 15, so it's like becomes 30 plus 16 by 2, I guess. And then if I do p by say 23 or something of that sort, right? Wait a minute, brother. Let's go back real quick. There's a pretty good hint here. So I know that 3 by 3, 6 by 3, 7 by 3, 11 by 3 is gonna be okay. So it's gonna be ceiling. So if I keep taking the ceiling of this thing, right? So if I do like math.ceil of this thing, what would I get? I get 6, right? I get 6. And is that equal to our edge? It is, right? So okay, fine, I kind of get it. So it's got to be math.ceil, I guess, right? Or I could just do like ceil, and I can do like from math imports. Okay, import all, right? So it's gonna be like my h mid is gonna be something like this. If my h mid is say greater than my high, right? Sorry, not high, h. If my h mid is gonna be greater than my h, then it essentially means that my low becomes mid plus 1. If h, okay, if h mid is less than h, high equals mid, right? And else it means that both of them are equal, right? uh, Return mid, I guess. I don't know. Let's see. But okay, I can't just return mid because mid is not a it's actually an integer only, right? So let's see. I just want to do like a one run and see what happens with this. None value is not valid. Okay, what the frick? What the sigma, bro? Integer and none type. What the fuck, bro? H is here, Pice is here, mid is low plus high. Okay, I'm just gonna, because I'm like a noob, I need to do mid as well, so I'm just gonna like do this and then do H mid and just run this and see what happens. Do they say that piles can be none? It cannot be none, right? So if I come here, right, I do low 38, so this is high, right? This is higher than what we wanted. Okay. Oh, okay. I get it. Okay, return mid. I guess I can just do break. I guess. I think I get it because it tried to return. It tried to exit the loop and it was like screw you and so on and so forth. Okay, let's see. So why did it fail here? It was like 1 and 11 and the mid was 6, which makes sense, and the H mid was also 6, which is oh, I think it should have been -1, I guess. I don't know. Okay, let's see. So this one was like, okay, it started with 1. This is fine. So 11 6, because it was 6 and it was less, then my high comes down to 5, which is this. My mid came to 10, which is still higher, right? My H mid is still higher. How is my H mid still higher, dude? Like, how is this shit higher than what it was previously? Like 3. Okay, earlier it was lower. That's why my if it's lower, my high moves down, right? But if it's higher, my low moves up. So it's like 4 and 5 now, which makes sense. Now for this one, let's see what the issue was. It did 130. So it did 15, which is higher than 8. Sorry, it did 15, which is higher than 5, right? So my low needs to update. So my low became 16, right? Low became 16. My mid became 16 and 30. 16 and 30. My low became low became 16, high became 30, right? Mid became 23 and H mid became 6. If my H mid was greater than H, which is supposed to be okay, my H mid was supposed to be 6, which kind of makes sense to me. H mid became greater than 5, so my low updated and became 6. 15, say 24. So then it became 6 again, which is still higher than 30. Okay, so it became 28 and 30, which is like, why did it output 29 though? There's no reason for it to output 29, right? Oh, okay, that's because low is less than equal to high, I guess. Let's see what happens if I do this then. Is there anything that it could happen? Oh, okay, hold on. Let's see what happens. Like when it became this, it became this. Okay, think this could be it, but let's see. I'm not sure. Right? Are there any edge cases that could not work? Right? Like could maybe take too long to solve. Wondering, is this break a good idea? Not sure. Only one way to find out that is actually submitted and see what edge cases we are missing. I'm pretty sure there's something that will mess up. Okay, so let's use this test case and see what happens. So running this 6.9, the output came out as 1, whereas it should have been 2. Let's see why is that the case. Right, like why is this of course this kind of makes sense to me because like at first we start with all of these things. My h mid was initially this thing, it eventually started going down, and when it went to 2, when it went to 1, why is this even getting counted though? Like it shouldn't it be that my h is 1 lesser than my actual time, right? So there is one simple thing that I can do is if h equals the length of this, I know that if length of piles equals h return max of piles, I know this is going to be like an obvious edge case that just works. Wait, what the fuck? Oh, of course you don't need to do oh, this does not work then. Okay, I see now. Oh, okay, my bad. I was kind of deluded, I guess. So here's the thing. I can see it from here that he's doing like just one banana every like hour, but I know that there's just one less hour, so it's like you can't do one for sure, right? What is it that's causing it to break though? So it does 1 3 2 and you get this big number 156442235, right? And then finally you get this, but your mid has changed now. Why is your mid changed though? Because you did 3 1 and 3. Okay, you know what, I'm gonna look at the solutions because I don't want to spend too long on just one stupid problem. I don't need binary search plus optimization. Let's see. This makes sense. Ceiling of I by k. K is 1. No, not this bullshit. Brute force, not this. This is brute force. I don't want brute force. Just fucking give me a binary search solution. No, like why are they trying to be over smart and like I hate. I'm gonna download this just because you wasted my time by giving me non-optimal solutions first. Like I obviously know how to do it with why can't I download this? What the okay. Anyways, that's just annoying because yeah, very annoying. Because but anyways, so I got the upper limit perfectly right. So sum of piles by h. Okay. This is the. I mean, this makes sense. Like we'll at least theoretically need this much, I guess. Makes sense. Makes sense. I'm gonna change my low as well. Then I'm gonna be like seal of some piles by h. This makes sense to me. Now, this is fine. Mid is fine. Total time. What is total time though? Is zero fine? Whatever. So for I in total piles, right? This is h mid essentially. We're doing this. I'm just doing it in a list comprehension. If total time is greater than, oh, I love that he's essentially breaking the loop early on if it's greater than h, which I kind of respect, bro. If total time is less than h, you just less than or equal to. Oh, I see now. I see now. And you're just returning the right one instead of the entire thing, I guess. Okay, let's see if someone else did it in a better way. Most words is fine, I guess. Do something. I like that it's essentially the same thing that they do. It's okay. I kind of messed up my basic binary search algorithm. That's the issue, right? I haven't done binary search in ages, it seems. I love that he's also using one as min, and this guy's was another guy was using some other min. I kind of like it. Both are pretty good estimates. Like you would at least theoretically need average of that. So I kind of get it. It's kind of cool. So I know that low and high needs to be this mid is perfect. This is always gonna be. You should never do unequal, right? And the way you're doing it is if you're sufficient, it's essentially asking if your h mid is a less than or equal to h, your sigma high is mid. This is what we had done earlier, and you never do an else. You just do uh, an if, I guess. So this should technically just be an else because your high is just going to be mid and your left is just going to be mid plus 1, low is just going to be mid plus 1, I guess. And you are returning always. Oh, okay, I was trying to store it all in mid, that was a bad idea. I should always return like one either end because that's where everything will be, not the mid. So let's just see. Let's just see. Right, this makes so much sense now because okay, so let's do one thing. Let's like do a note on this. Right, this is a pretty good uh, question in general, I guess. I'm just gonna copy this. I'm gonna get rid of this one. I'm gonna submit this and then we'll just make some notes on this. 96. That's pretty good, I guess. That's pretty good. Pretty good. Pretty good. Pretty good. Cool. So what I'm gonna do is I'm gonna open my uh, queue. Let's do one thing. Gonna see if I can open my iTerm now. Cool, I'm in iTerm, so you know what? I'll just do nvim, right? And let's just see what all things do we have. If we go to inside LC and say I want to create a new file, right? I know a new file is simply just typing a and I will just call it, let's see what was the problem number. It was Coco eating bananas, but what was the problem number? Okay, so I'm just gonna call it lc875.py, and I'm just gonna go in here, and yeah, I'm gonna be like boom, right? This is gonna be the solution that I put in. Let's also put in the test cases, right? Like I'll just do piles equals whatever, piles equals let's say, okay, I can just like copy paste it from, right, h equals say 6, s equals, oopsie, solution s dot, okay, so just printing s dot min eating speed and piles comma h, and okay, what the heck, oh, of course, so we need to like from typing import all distance, because this is like 23, this is pretty good. So I'm just gonna be like oopsie, 23g is just gonna get us to the 23rd line, I guess, and oops, oopsie daisy, right? I know shift dollar just goes to the end, whatever. So that's one test case, I guess. Let's just do another test case that was oopsie, and again this one, right? So this is pretty good. Now let's write a oopsie, what am I doing, man? So reflections, right? So let's write some reflections. What all things did I do wrong here? The first thing that I okay, things that I did incorrectly. Forgot how to write the basic binary search loop. This is a big one, important. So the basic struct should be as such. The basic structure should always be some low high equals 0 max something, I guess, I don't know, while L is less than high. So you always do this, you do M equals L plus H by 2, and that's gonna be a mid, and if something, if function of mid, so you gotta essentially check if you gotta first check if your function of mid is doing something, right? You take your mid and satisfy, right? Right, and right? So it's always going to be, if your mid is satisfied, then it's always R equals M, or the sigma, bro. M equals whatever, sorry, right, left, sorry, high equals M. What the fuck, man? This is so annoying, dude. Okay, so this is just annoying because yeah, high equals M, else low equals M plus 1, right? You go ahead of mid, so you never do 1, which is yeah, you return L, right? So this is gonna be like your basic structure. What if it is happening from the other way around, like if you are, instead of doing M plus 1, right, a simple pattern. So there can be left fixed pointer and right fixed pointer, right? Left fixed pointer, right fixed pointer. Yo, testing 1 2 3. Hold on, hold on. You know what? Something very annoying is happening. Disconnecting this. I'll be back. Testing, 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 testing. Okay, cool. I'm back. I'm back. I'm back. So the issue was that all this time, like somehow my microphone was being connected to my fucking iPhone, which is so annoying because this is just, yeah, this is just annoying because I don't want my microphone to be listening to my iPhone microphone to be capturing my audio, right? That's just annoying, right? Anyways, so let's just what we were doing, right? Okay. Okay, so this is just sent items. I'm just gonna check one important email. Okay. What the sigma, bro? Okay, so okay, I think I've figured it out. I think I figured it out, which is pretty awesome. One of the biggest anxieties that I had just got relieved, by the way. So congratulations to me. Yo, yo. Okay, hold on. Something's wrong with my audio because yo. Oh, what the heck? What the heck, bro? What the heck? Yo. If I have like such a high pitched, okay, so for some reason my microphone cutoff was set to like super high. So now I've set it to like 23% in my. You see, here it was earlier like set to super high, but now I'm setting it to super low, like 23, 24, whatever. So, woo! We back, baby. Cool. So, this is the general pattern that I want to keep in mind, right? And let's see what other mistakes I did. Was the biggest sin was actually not knowing uh, the basic binary search algorithm, which is just embarrassing and sad, but it's okay. Next, uh, did not immediately think of applying binary search to the problem space, right? So, right, don't just think of using binary search on an array and start sorting it. Perhaps you can try to do binary search on uh, binary search to improve your brute force approach. Cool. So this is one thing that I could do. So I'm just gonna save this. Git add lc git commit lc875.py. This was a binary search. Cool. So we'll come back to our browser and let's do some more, I guess, binary search questions, because this was like a pretty good one. Let's see, finding minimum in a rotated array. That's one. Let's open up two more, I guess. Okay, so we can just do this, I guess, and then I could do some backtracking questions, because it's been a while since I've done backtracking and I'm almost like forgetting the basic algorithms, right? So I actually need to do one thing, like I need to start making a nice note in a way, I guess, right? I should essentially keep I have a document, like a Google Doc, where I put all my patterns, like for every question. I could perhaps do the same in here. I need to go through the notes, so I could perhaps solve 2 or 3 more questions, or 4 more questions. 3 more questions should be good enough, I guess. And then I can perhaps let's see. Anyways, there. Okay, find minimum in rotated sorted array. Suppose an array of length n sorted in ascending order is rotated between 1 and n. Let's see. 1 and n. Okay, cool. Cool, baby girl. Cool. What microphone am I using though? Standard, right? Mic mode is standard. This is pretty good. Yo. Okay. Cool. Suppose we have an array of length n sorted in an ascending order is rotated between 1 and n times. Oh, okay. For example, the numbers 1, 2. Okay, so this is sorted. Might become this after it was rotated 4 times. What does rotated 4 times mean? Oh, okay. So it's just like shifted. By rotation, they kind of mean shifted 4 times, I guess. Like it was rotated 7 times, it becomes a normal thing. Notice that 1 time results in an array of n minus 1. Given any sorted array nums of unique elements, return the minimum element of this array. You must write a program that runs in O of log n time, right? Okay, this is a pretty good question. So I know this is how my array has been. Okay, so you cannot do n, because you cannot try to find the max and then do a binary search, because that would just be criminal. That would go against the principles of, that would go against the log n requirement, so you can't do that. The ordinary array was 1 2 3 4 5 rotated some n times and so on and so forth. Right. Cool. So we know there is some sort of order, right? So I'm gonna open up maybe I'm gonna open up I want some scribbling thing. So maybe x Excalidraw. I don't want Excalidraw because online whiteboard scribbling simple something, I guess something of this sort I need. I will never do a wide virtual thing, whatever, whiteboard fox. Anything without ads would really help, I guess. No, screw this. This is too much options. I don't want something this fancy. This is also too many options, I guess. Onlineboard.eu. Why is no one letting me open a board right away? Like, this is the amount of hops that I have to do, before I get to a board is just annoying. Again, annoying. You are asking me to do a sign in. This is annoying, man. I don't need this shit. Nope. Oh, come on, man. Scribble together, not into it. Why didn't I click on scribble together, by the way? See, the problem with this is everyone is asking me to do multiple steps before I get to my destination, which is not what I want, right? Okay, you're not. MS Paint Online. Someone should have done MS Paint Online, right? Like, perfect, dude. This is all I needed, right? There's too many ads here. I don't like it. Dude, this is beautiful. Okay, I love this. So I'll take a brush. I'll take like a real big size. Awesome. And undo is Control Z. So let me try this. Cool, perfect. So let's do this, right? So I know that traditionally our binary search has an array of this sort, right? Traditionally our array is of this size, and this is our low and this is our high, right? And we usually are looking for and this is usually like our mid, right? Now here is the deal. Okay, here is the deal. You wanna your array is gonna be rotated, right? So it's not gonna completely lose its structure. It's gonna maintain some structure. It's not completely shuffled, right? So our job is to find the minimum element of this array, right? So if it was sorted, we'd know that it's just this. But currently our array, for example, if I take the first one, which is 3, 4, 5 and 1 and 2, so it's essentially the array kind of looks something like this. Sorry, if this is like the magnitude of the array elements, say this was like 1 and say this was like 5. Now what I have is my array kind of looks something like this. The magnitudes look something like this, I guess, and then this, right? So this is how my array looks. My low is gonna point at something, my high is gonna point at something, and we do not know if that's gonna be the highest element ever, right? So suppose instead of pointing, suppose I do point the same, where it just points somewhere, like suppose this is like my mid, right? Now let's say this is suppose 3, this is suppose 5, and this is suppose say 2. I check my mid, I check my low, I check my high, right? Now if I have a situation where my high is lower than my mid, right? If my high is lower than my mid, what does it imply? Okay, let's look at this one. This is like a normal array, right? And suppose instead of just 5, this was taken away and this was just put at the very beginning, and my lowest was just one element after my index 0. Say this just was here. So what cases would I have, right? Suppose I have a high less than m, right? The element at high is less than m, which is this one. What it means is my min lies to the right of my mid, right? So my low has to become my m, right? So it essentially becomes this. Now this case essentially is this one. What happens if my high is higher than my mid? If it's higher than my mid, it means that my high essentially needs to be my mid, right? So this is what it comes to. And what if I do a comparison based on low instead? Like if I say my low is less than high, if my low is less than mid, right, does it tell me anything? If my low is less than my mid, doesn't tell me much because it's still in an increasing order, right? If my low is greater than my mid, it tells me that my uh, okay, so I need to essentially compare high and my mids rather than low and mids, and it should always be that high moves back or my left moves to mid, right? So high should either become my mid in any case, or left should be mid plus one, I believe. And I should be returning a left in general, right, at the end. So I'm just gonna do this again. So L is 0, H is len of, okay, sorry. L and H is gonna be 0 and len of nums, right? Oopsie daisy, this should be nums. While L is less than H, I guess, M is gonna be again the usual L plus H. This is gonna be my mid. Now what we gotta check is if my nums of high is less than or equal to nums of M, right? What does this case mean? If it's less than this, then my high is essentially M, else my left is going to be M plus 1 and return should be nums of L, I guess. This is what I'm thinking I would do. Right, this is what I'm thinking I would do. Not sure if this would work, but let's see. Let's just do one test. I should have looked at the constraints. Hold on, what the issue is? Oh, okay. Should be nums minus of 1. My bad, bro. My bad, bro. Had a brain fart, bro. No, something went wrong. So it did 5. It did 5, exactly 5. I do not want to ask, well, fuck Copilot, man. It did 7. It did 17. So it's essentially off by 1 is what I'm seeing here. Right, it's off by 1. Why is it off by 1 here? If it's oh, is it because of the equal to sign? Let's see. Is it because of the equal to sign? No, it's still the same. Off by 1, off by 1. Let's just keep this as it is. Alright. Hold on, thinking. This should be right, but there's some issue with this where why is it off by 1 is a question that I have, right? It does 5. What is my L currently looking like? Okay, hold on, let's just do a print of nums of L and nums of H, I guess. Both of them are converging to the same numbers, and this is essentially resulting in the highest number rather than the smallest number. So which is again, like, in a way we are doing a converging to the index that gives us the highest number, right? So it essentially means I could do this and this. Maybe this could essentially just I don't know. Not really. I don't know. This might just break. I'm just trying things. I shouldn't be doing this, honestly, but whatever, right? Of course, this doesn't work. My bad. So I know that this is L plus 1, right? This looks pretty good to me, honestly. So if my H mid is, if something is satisfied by this, right? So we'll do this. Okay, so I know what I can do. Since it's converging to just the highest number, I'm thinking, how do I make it converge to L, right? So I know it's going to be the immediate next index, but I just want to do it naturally rather than like forcing it. I know the answer is simply just doing L plus, like if I just do like L equals len of nums, maybe, I don't know, whatever, right? I can just do like plus 1 and percentage of whatever L, right? So if it was like, if this one was 0, 1, 2, 3, it would have been 3 plus 1 percentage something. In case it was here, it would have been 1, 2, 3, 4, 4 plus 1, 0, 1, 2, 3 plus 1, 4, 4 percentage 4 would have been 0, and then would have landed 0, whatever. So could have just done L plus 1 percentage L. I know this would work, but I don't want to do it like this, honestly, because this just I just wanted to naturally fall over here without doing this. But let's just do like a dry run. If my LO is less than H, and if my number of, so I'm always incrementing L by 1, and when is it that L is stopping, right? When is L stopping is my high is always getting compared to a lower value, right? It's, we are essentially saying कि मेरा high अगर mid से lower हो तो तुम high पीछे लेके जाओ. So if I go to paint, if my high is lower than this, I always come to my mid, which is like this 5 thing, right? And right, it essentially comes to the 5 thing, and L is just going plus 1, right? If I instead tried to see what is the relation between L and M instead, let's see. I know my L, agar L is greater than my mid, then it means that my if L is greater than mid, okay, if my L, this L is greater than my mid, right, then it means that the H needs to move to M, right? So I move H to M, right? I move H to M. यहाँ पे आ गया. So it's something smaller now, right? Now I see my mid is this. Now I see is H greater than M. It is. So I keep moving H here. I cannot discard the current M, because discarding the current, like if I do M plus M minus 1, then it can perhaps reach here and again ignore the greatest value. So I can't do that. So H has to be equal to M in this case, at least. It keeps doing that till there'll be a point when H is here, M pe, yahan pe, and my M is currently L plus H by 2, so it's always going to be converging here, I guess. And I'm guessing if I do L plus H plus 1 by 2, it could perhaps do one index aake, like it could perhaps do something over here, right? Let's just do that. Let's just try that, right? Like if I go here and if I do L plus H plus 1 by 2, it's gonna fuck it up, but let's see what happens, right? It's obviously gonna fuck it up, but what, it doesn't fuck it up? How does it not fuck it up, bro? Hold on. So L plus H plus 1 by 2 is kind of working. Whatever. What the fuck? Hold on. Why was I misled then? So H comes here. It becomes like my mid and H becomes the same. So if it's 0 and 1, suppose I do plus 1, right? And 0 plus 1 by 2, right? Then it essentially becomes 1. That's when it lands here. So I'm happy with L plus H plus 1 wala arrangement. This looks pretty good to me, because then I'm moving H always to M, which is this thing, right? And what I was checking was if L is greater than M, right? I was checking if L is greater than M. You move H and you return H as your answer. In this case, what would happen if L is less than M? Then it means for sure that my minimum. So what does it mean if L is greater than? Doesn't mean shit, to be honest. If I'm being honest, it doesn't mean shit. But that's just what I would like to feel. That may not be right. Right? Anyways, let's just see. This seems to be working, but I wanna see someone else's solution and see how they did it. I don't know if this will work, if there's some edge case that I'll fucking fail on. Could be an edge case that fucking fails, but it takes too long, which is sad. Why is it taking this long though? Huh? What the okay, hold on. What the fuck, bro? This is the issue. Come on, dude. The moment I try to like change a little bit in my code, it shit fucking blows up. This is also gonna exceed time limit. Is that the case? Why, bro? It's gonna exceed time limit. What the fuck? Yeah, it's gonna exceed the time limit. But why? And on what input though? Let's see. Oh, fuck you. I did this, which is right. Mid equals L plus R minus L. What the fuck? This is literally what I. Oh, okay. Hold on. What's the issue here, bro? Anyways, let's see. There's a network error. What the fuck? So, hold on. I'm gonna check one thing. Okay. M and this. I just wanna see what is the difference. Like, there's of course no H. My bad. So 2 and 4, 1 and 2. What the fuck? 3 and 6, 1 and 3, 2 and 3. What the fuck? Hold on. What happens if I replace this with sorry, if I replace this with this? Just curious, man. Like, does this even run? Because the conditions are exactly opposite, right? If hold on, what the fuck? If nums of M is greater than nums of right, hold on, this should work ideally, right? I think this should work. This, I kind of get it, just opposing the conditions, but this doesn't work. Hold on, let's go to the solutions. Why did this not work and this work, right? Fucking asshole, doesn't even work. Why would people give solutions that don't work, man? I know the solution, I'm just trying to see where did my code go wrong. Mid is left plus right minus left. Huh. This is such an interesting way to put it, right? Like, instead of doing left plus right, they're doing this. Oh my god, bro. Did I write the condition wrong? What the fuck? You're saying this should be M and this should be like an H. This is what you want me to do? But you are saying that this gotta be like L plus H minus L. Okay, hold on. I need to digest this. Why did this tiny change work? Of course, this needs to just be L because, of course, we no longer need to do this bullshit. Hold on. So, H minus L by 2 plus L. What does this give though? Let's see. So H minus L and L plus H. So what do these two things do, right? If my mid is smaller than the right. Wait, what the fuck, bro? What the fuck, bro? So you're telling me that L plus H by 2 is the same thing. Do you not need this shit? What if I submit this? Ideally should never change, right? So this shouldn't change, which is right. Mid calculate करने का कोई और चूतिया तरीका क्यों दिया था उन्होंने, मेरे को पता नहीं. Why did I do that? I don't know. That's fucking stupid. But let's see why my condition was wrong. I was doing H less than equals M. मैं देख रहा था मेरे चार्ट में कि अगर मेरा मिड right, if my mid is higher, if my H is smaller than my mid, and यहाँ पे वो बोल रहा है कि जब तुम्हारा high है, okay, the condition that seemed to work is when my mid was smaller than my high, which is whoopsie daisy, this, when my mid is smaller than my high, low is smaller than my high, it is saying कि भाई तुम्हारा condition same ही है. It's like you're reducing the problem to just this. Okay, I get it now. It is reducing the problem. Bro, honestly, not gonna lie, bro, both should have worked. I kind of get it. It's just reducing the problem to a smaller subset, I guess. You know that if it is bigger, then it can only be this case, and that's why you're like reducing it. And you are saying कि ये हाई कर दो और तुम्हारे पास यहाँ पे ऐसा हो सकता है कि ऐसा कुछ तो है, right? And in that case, अगर तुम्हारा mid यहाँ पे है और it is, suppose तुम्हारा mid यहाँ पे है और तुम्हारा high से ज़्यादा, तो you gotta move your L ahead, I guess. ठीक है, that makes sense to be honest, not gonna lie. Okay, anyways, I don't know why the other one didn't work though. Let's go to submissions and check. ये जो हवा था, don't show you the test case, huh? Oh, they'll show you the test case, okay. This bitch outputted 3. This was the code that I ran back then. So my low was obviously 3, high was 2, and it said that if my mid was obviously 1, and it obviously said if 2 was less than or equal to 1, which it is not. So my low is gonna become mid plus 1, which is 2. Low is gonna become mid plus 1, जो कि 2 हो गया था, जो कि 3 हो गया था essentially. Oh my god, bro. I get it. Low-key, bro. I get it, bro. ठीक है. This kind of makes sense to me now. Why this fucking failed, but unfortunate, very sad that this we couldn't catch it earlier. But these conditions, right? Like, gotta figure it out. Why? Get it that 3 would essentially go to 2. So the reason why I like to avoid these bullshit adjustments is just because these adjustments usually never work. They always fuck you up real bad, right? Anyways, hold on, let's kind of figure out a way to not avoid this mistake forever in the future. What do I do to keep this in mind, right? Like, if I say compare this with, oh my god, come on, dude. Hold on. Wrong answer is right here, right? So if I compare this with my wrong answer, it reduced the problem to a smaller problem and then converted it, right? Like, instead of doing, it said, the moment it said that my high was greater than my mid was greater than my low. Oh wait, hold on. This is my incorrect code. Like, it said the moment I see my high, which is less than my mid, I moved my mid height. What the fuck? Dude. What the fuck? Oh my fucking god, dude. I had a brain fart here. This condition was never wrong. Like, when you... Okay, let's clear this. How do I clear this shit? New. No. Right? If I have this condition, right? And then a little bit like this, I guess. Say my mid is this and my high is this. This condition was, अगर high mid से छोटा हो तो high को mid कर दो. ये गांड से निकाला था बेंचो. This is wrong. Oh fuck, dude, this was so obvious and so stupid, and I had a brain fart on this. Obviously, this is such a incorrect condition, and I was like so confident that this was right. So essentially, I was saying कि if this is smaller, you move h here, we move h here, and then you're essentially excluding the solution itself, which is so stupid, right? Right? My man, I should have instead done this here. Right, let's do this, okay? If I take my original solution right here, right? This motherfucking solution right here, and if I just did, fuck you, please. Let's close this, please. Wrong answer, screw this, right? If I do this, if I should have done L equals M plus 1, otherwise I should have done H equals M, and this should have been just L, I guess. If I do a run here, This still works. Fucking worked. Okay. I just had the conditions in reverse, which is so annoying, so embarrassing. This is just very sad, man. This is just uh, a disgrace, right? Like, man, गलत हुआ ये, गलत हुआ, बिल्कुल अच्छा नहीं हुआ ये. I had a brain fart, man. This is so fucking stupid. Hold on, I need to write this one down too because this is such a simple solution and we messed it up real bad, right? So let's go to lead code and let's do uh, ALC. What is this lead code problem number? It's 153 153.py, right? So this is gonna be my sorry, gg, oopsie, from now s equals solution s dot find. Okay, so let's just put it like the print s dot find main, and yeah, whatever, like let's just get some test cases from here, I guess, and maybe a few more. Python lc 153, for example, 0, right? So that makes sense. This is correct. And again, if I'll just do one more test case, if I get oopsie, $11, so this is pretty good. So let's just do some reflections. I had a massive brain fart when writing the comparison operator. I wrote if nums of h less than equal to nums of m, h equals m. Come on, dude. I don't want this. This is so annoying, dude. Okay, I'm still learning this, so this effectively removes / ignores the solution. Why did my brain not process this? Okay, so again, this is just probably has to do with some mild form of dyslexia, I guess. My brain just why did this not work, right? Like, where did I go wrong here is my question. Like, this is obvious, but where did I go wrong? Like, comparisons, like doing numerical, like simple arithmetic should not be a big problem, but it sadly is right now. So I'm just wondering, why is that even? So if I were to look introspect a little bit and like trying to see, Thinking. Okay, anyways, let's go ape shit. Uh, my brain just did poorly at arithmetic, matic, comparison, whatever. So this is just fucking stupid because this is like a completely avoidable mistake, right? And man, I'm just upset that man. Oh, life, man, life is fucking. Simple things should not be causing such a huge brain fart, right? Like a thing to keep in mind for me would be to like just do decently at arithmetic, like basic arithmetic, man. Like I can't fucking mess up something this easy or this fucking simple, man. This is just so annoying, man. Ugh, ugh is the only thing that comes to my mind right now. Fucking hell, bro. Fucking hell. So just annoying. Can't be. Okay, shiz. I need to. Hold on. Oh, I need to see if I can get into. Okay, cool. So, gonna real quick go here. Beautiful. Okay, I just got some really good emails that just have uh oh, they're okay with just sharing it online, which is, oh my god, dude, life is just so good right now. Life is just so good right now. She's okay with just, ooh, god, this is so good, bro. Bro, this is awesome. Like, life is so sorted right now. I had just a huge worry about my scholarship and like figuring out how to pay my scholarship, but I've just found out that I no longer need to be worried about the mode of payment. They are just okay with paying directly to my whatever fucking, yeah, whatever. Oh, whatever, brother. Anyways, fucking hell, bro. This is awesome. Life is so good right now. I'm just fucking relieved right now. Whoop whoop. Okay, sorry. In a way, this was good, but I know that I need to fucking lock in right now. I need to lock in hard. Like, I need to lock the fuck in because I have like three interviews coming up, all for like senior ML engineering positions. But if I don't get my shit together, bro, I'm fucked. Oh my god, baby girl. Okay, sorry. Let's lock in again. Let's fucking lock in again. Right? So, okay, I'm gonna lock in and I'm gonna like start doing. I'm just happy that the payment thing is sorted right now because I no longer have to worry about anything. Like my I'm just taking such a deep breath. Sigh of deep breath, bro. Man, I'm so happy right now. Fuck. Fuckity fuck. Man, I just know one thing now that I need to lock the fuck in opportunity चल के आ रही है दोस्त. Gotta fucking like sacrifice on sleep, sacrifice on fucking anime, whatever, bro. I just gotta like log the fuck in right now, and I just gotta have like one singular fucking goal in mind, that is to get a fucking job, bro. Get a fucking job, mate. Okay, my English, my British accent is kind of shitty right now, but I'm gonna work on it. I'm gonna work on my American accent as well. Cool. Time to solve another lit code question, right? So this is like a very basic one. This is just subsets. Like I absolutely love this question. Fuck this, fuck this, fuck this. Subsets is like one of the easiest backtracking questions. The reason why I love it is because it has this cute pattern of you just have to maintain a path outside and an answer outside. And the way you do backtracking is this pattern, right? Like you don't even, I've stopped like thinking through, or I've stopped like rationalizing this pattern. I'm like, okay, if I want to do subsets, I just gotta do this pattern. I just gotta type this shit out and then it works. So you know what? I'm just gonna train my muscle memory right now, and just gonna reason through as I write this again, I'm gonna reason through why this works. And yes, and then we'll work, baby girl. Okay. Man, I need lead code. I know I need lead code premium if I wanna get into like some elite like forums or something. I don't know. Man, I fucking hope I get in, man. Fucking hell, bro. Fucking hell. Fucking hell, yeah. फल की चिंता नहीं करनी है बहनचोद, बस पढ़ना है. ठीक है, करते हैं, पढ़ते. Okay, anyways, this fucking boom. So we gotta train our muscle memory at this point. I know the answers. The solution definitely is gonna pass, and I'm gonna be like back off and return answer. This is the basic structure. Now what you gotta do is, first of all, you gotta do non-local of ans and path. Very important. Now this is a very simple problem. We first do a backtrack of index plus 1, right? Then we do path.append of index, sorry, nums of index idx, sorry. Then we do backtrack of idx plus 1, and then we do path.pop, right? So this is what we do. Actually, take it back. It should be this, I believe, right? You first append something. So here's what's gonna happen. I go to 1, I append 1 to my path, right? I append 1 to my path, and I do backtrack of index plus 1. I append 2 to my path, I append 3 to my path, and then I say that, hey, you know what, I've reached 3, which is my exit condition, which is gonna be like if idx equals len of nums, right? Answer dot append path dot copy, and you just do like a return. Cool. And I did 1 2 3. I came back, I removed 2, and I went 1 index ahead. So I just did 1 and 2, and I said, hey, fuck you, right? And then it reached this, came back, popped 2, and in the end it's essentially, so it's hard for the brain to capture this in like a very nice way. It's a little bit hard for the brain to like visualize this. You don't have to visualize this, but all you got to realize is it's gonna do it the other way around. Ulta karega, obviously. 1 2 3 1 2 1 3 1 2 3. This is exactly the way of creation. So 1 2 3 पुश हुआ, इंडेक्स यहाँ तक पहुँच गया, और उसने बोला कि बैंड के लंड अभी पॉप कर दे 3 को, and then the index is still gonna be at 3, and the path will not have 3, so it's gonna be this. Same goes with 2, you get 1, you get 2 3 2 3, and then this. Perfect, this is beautiful. We'll submit this, and we'll just like mark this as done here. We have done this, of course. कोको ईटिंग बनेंगे ना, मिनिमम ये भी हारी भी हो चुका है हमारा, राइट? Let's do combination sum first wala, right? Combination sum is also like a pretty different, it also has like a pretty specific pattern. Actually, can we do subsets too first? Like maybe it could be like a smaller, it should kind of contain like the. So one option that I'm thinking I can do is like every time I append, right, I can see if there is a tuple in there, right? It could be kind of like, see, the answer should be simple, right? Answer should be this, path should be this, right? And you should essentially have def of back. There should be some index here, non-local of answer and path. You do a pass for now, you do a back of 0, you return your answer. And what you will do here is you can do path.append nums idx plus, okay, idx, you do back of I dx plus 1, you do path.pop. Okay, you should have done back of idx plus 1, right? Oh no, my bad, bro. Both should ideally work, I guess. I'm wondering if both of them do work in any way. Because if you keep doing idx plus 1 first, you should be entering this sequence first, right? I'm just curious, like this is what I have, right? What if I do this first? Like what if I do this first? What is the sequence that this generates? Does it generate it in the A order? You see, so you putting this here or here does not matter. It's just getting it. I'm getting it now. Cool. So let's not this, subsets 2 is what we were trying to do first. So subsets 2, right? So this doesn't matter what we're doing, it should work, right? For okay, if idx equals length of nums, I gotta do a return here, but here's the thing, here's the kicker, right? You do a if tuple of path in ans. Okay, let's just do ans as a set maybe for now. If tuple of path in ans, if tuple of path not in ans okay, p tup is tuple of path uh, p tup otherwise return. So if that tuple exists, right? If p tup not an answer, you add that tuple, right? Otherwise you return, and when you are getting out of this, right, you return a say uh, you gotta do like a list of lists, right? So ans equals list s tup for tup in ans. I don't know, this could work, I guess. I'm hoping, but there could be obviously some edge cases that don't work. So this works. So what if I do this, right? Like what if I do this? It should perhaps give me the sequence in the way I had expected. No. Let's see how fast this is. I'm guessing there could be like a faster way. Oh my god, dude. Let's see. There's obviously okay, I've solved this once before and I get it. I get it. Oh wow, this is much different in structure than what I had in mind. You're sorting the numbers. Wow. Dude, you're sorting the numbers. This is wild. And you're adding a path, which is fine, I guess. It's fine. You add this to the path. For I in the range of index to the length of numbers, if I is greater than the index, which is fine, which is like and number of I equals number of I minus 1, you continue, which means that so it's like greater than idx, like it's not the zeroth element and not the index idx element, and if the previous two numbers are the same, if the current number and the previous number is same, you continue because you just don't wanna worry about it, right? And you just say, did I read the question wrong then? Hold on, maybe I read the question wrong. That's not return duplicate subset. Okay. Oh, I see. So if the subsets cannot be duplicate, this is the pattern that you use. Okay. This is motherfucker. I knew this, but it's just been ages since I have done any backtracking. God damn it. God damn it, baby girl. We thought we had it, but we did not have it. We kind of fucking failed. Why must God punish us like this, brother? Why must God punish us like this? Huh? Sorry. So, you did a num search start. You started the numbers and so if you do not want things with duplicates, right? I believe this will also happen in combination sum too, because combination sum will be like give me combinations and combination sum will be like give me the combinations but without duplicates, and then you'll have to do this for loop bullshit. I'm pretty sure. Right. So actually, you know what, baby girl? Let's do that. Let's do that, right? Hold on. Before I do that, right? Let's do one quick thing first. Man, I need to be more thorough with my practice. Okay, so it's 5 right now. So, what I do need to do, okay, it'll be 5 in like 20 minutes, but post that, what I would need to do is, Okay, I get it. Hmm. Life is good, bro. Life is good, bro. What was I doing again? Sorry. Hold on. Let's figure out if we have to do like one, two, three. Total three of deep ML questions, I guess. Transpose of a matrix times matrix is harder. Just trying to see other questions that I need to go through. Man, there's so many of these that I need to go through. Motherfuck Jin Yang. Oh, sorry, that's just a dialogue from. I'm gonna quickly go here and see core skills, ML, what all things I need to do. There's a digit classifier, there's a PyTorch training, there's an intro to NLP, that's fine. Code GPT, make GPT talk back, that's fine. PyTorch training is easy. Digit classifier should be should be easy, you know. But I need to get through all of these. Data structures is fine. Fuck this. I'm not doing this bullshit. Dude, I'm not doing segment trees and shit, dude. Why do I want to do? No, no one's doing segment trees, bro. Not doing merge sort either. I'm just gonna do this. Sure. Anyways, let's do neat code 150. Let's see how many of blind 75 have I done, right? Like, oh, okay. So blind 75 is mostly like hard problems, I believe. Word search, I've done word search. I've implemented these. Okay, so I think kind of getting it that these are only hard problems. Intervals. I need to get on intervals. Greedy is important. Rotating image. Sure. Spiral matrix is straightforward, I believe. Sum of two integers. Okay, I think I can just solve sum of two integers after this because I don't know. I'd wanna try that, I guess. Let's see. 2D dynamic programming. I've solved most of these, I guess. Longest unique path, fine. Dynamic, I guess. 1D dynamic are pretty. Why must God punish us like this, man? Right? Think about it. Yeah, that's just how God is, bro. That's just how God is, bro. Let's see. Okay, got it. So much to cover. Fucking painful, bro. Okay, time to lock in. Time to lock the fuck in. Okay, so combination sum. Let's not combination. Sorry, subsets two. Let's go to subsets two and just fucking. So we'll do one thing. We'll do two combinations. Okay, we'll go to subsets two, permutations, combination sum, and combination sum two. We'll just study these four and then we'll just say back up for the day for lead code at least, right? And then we can do a review of other ML stuff, right? Do a review of our own resume and I don't know, bro. Gotta study a lot, I guess. So much to study, man. Fucking painful is all I'm gonna say, bro. Let's see, what's the time? Why did you ditch me? Why did you ditch me? What's going on, man? Okay, sorry. Man, I was distracted again. My bad. And my study sessions need to be a lot more effective. I just need to put in so many more hours in this shit. Maybe what I will do at 5 is probably I'll just have one banana. Like a banana a day. Ah! Fuck. Man. If I'm live streaming shit, maybe I should not be crying so much, but the amount of inefficiency that this study session has right now is just horrible. It's sad, I guess. Just gonna trust. Okay, you know what? Like one of the most effective ways of learning these simple algorithms is actually to create Anki cards. Like these patterns, like these simple patterns. One of my favorite ways to do it is like just commit them to memory. And when you find the pattern in wild, you can just like make minor modifications. So I'm gonna try to logically understand this and then gonna try to implement this without looking. It's gonna be hard. But anyways, you first sort it, right? And in your backtracking algorithm, you are appending a path that you are passing down. Every time you pass down an algorithm, something from your path, you're essentially you're gonna iterate through index to the length of the num. So you're sorting it. So order has been taken care of, and because you have order taken care of, as soon as you hit a piece where your current is not the same as your previous, right? So if I have a sequence of 1 2, okay, if I have a sequence of 1 2 2 2 3, 3 4, then you get this appended in the path, right? You don't get these two appended, you get this appended and this appended, right? Right, this is what you get, and this is what is being continued. And you say that, hey, you know what, for every single of these you just go to index plus 1. So if I'm currently looking at this one, you look at everything ahead of this, and if these are, so this is taken care of, right? So this recurs this, and this has been taken care of right now by passing this in here. So this appears only once because this recurs, and since when you come back from the recursion, you know that this has been seen before, so you don't need to do it again. Got it. Let's do it. Okay, so I know answer is gonna be this, right? And def back will take in like an index and a path, right? You'll do a path for now, and you gotta do like a 0 and this. You gotta return your answer. And one important thing that we had done is like nums.sort. You had sorted this because order matters in this case, right? Now we had done anstat append of path for I in range of idx, say length of nums. You know what? We'll just do L equals len of nums. I don't know. I think it isn't an expensive call, but I just wanna do this. Maybe, So if idx, if I not equal to id, okay, if I equals idx, sorry, if I not equal to idx and nums of I not equal to nums of I minus 1, you do a continue, right? Otherwise you do I plus 1 and you do path plus nums I, right? And should essentially be the gist of it, right? Let's see if this works. Something went wrong in the first one. If my output got 2 1-2s, which is kind of wrong, it should have 2 2s. So this is important so that you don't essentially, by any mistake, you don't if you don't do this, this will go out of bounds for the very first thing, right? You can't do that. And sure, this makes sense to me. So I'm just thinking, I did empty first, then I did 1, then I did 1 2, then I did 1 2 2, then I did 1 2 again, right? This is kind of weird. Let's see, what did I fuck up here? Oh fucking hell, bro, this is not equal to but rather than greater than. This is interesting. So why greater and not equal to, right? Like, and this is equals. Fucking hell, bro. Oh fuck, of course. Why did I have brain fart in comparisons again, right? Like, I should have been seeing that if they're the same, then God, why? What the fuck? I mean, I know I'm fucking stupid, but why am I doing these basic silly mistakes, right? This is so stupid. Comparators. I need to write this shit down somewhere that I'm messing up in comparators. This I get. Now I get this because you need to do it greater than I. Because if index starts from I, index. Hold on. Right. I'm gonna use this test case and run it against this real quick. Come on, dude. So this works. So this essentially did not. This was not the issue. This was the issue, I believe. Let's see. Motherfucker. Okay, so all these basic backtracking questions, I need to keep these in mind because these are so basic, bro. Can't fuck these up at all. I need to like do these multiple times, I believe, because these are just like central, like these are like central to all things. The combination sum is like how many of these you can combine and make the sum. And this is just subsets, honestly. This is just fucking subsets, right? There's no difference between this and subsets. It's just instead of appending the path, you're essentially saying if the sum makes sense, you append it to the path, I guess. But there's one more thing that is happening here, which is, see, this is kind of like subsets. Oh, fuck no. Hold on. Hold the fuck on, bitch. This is not subsets. This is combinations. My bad. The difference between combinations and subsets is that subsets just requires you to take the same amount. It's like subsets. Combinations is you can pick the same number multiple times. Is what's happening over here. And this has a very different pattern, right? And the pattern essentially is that till you get that particular number from the array, you just do this for loop. So the for loops are a very integral part, I believe. Like you got like a target, you append shit to the target. If you have nothing left, then you're like, hey, you know what, bro? Okay, I get it now. I kind of get it. I'm kind of. Man, I need to like work till 8 and then like get myself a. Give myself like a tiny little break. So let's see. We have like four. Okay, five to six, 6 to 7, 7 to 8. Like 3 more hours, I guess. Shouldn't be too hard. Shouldn't be too bad, I guess. Should be too bad, bro. Real quick, I'm gonna turn this off and I'm just gonna see. Just gonna see some things, I guess. A few things that I gotta see, bro. Brother. Fucking painful, bro. I remember when I lost my mind. Okay, anyways. We should get back to our focus, things of focus right now. Anyways, my bad. Cool. Time for combination sum. So, again, I've solved this before. I just need to get get it back in my memory, I guess. Right? And I love that now that I've solved these questions, I love that I'm able to like kind of have somewhat of a decent recall of these questions. My god, I need to drink water. Fuck. I haven't had water in a while. How many liters was that? Was that like 30 for 500 ml? Is that like half a liter? Yeah, it's like 591, 600 ml. Okay. Anyways, let's let's analyze this question, right? Man, the amount of people that have asked this question is just so fucking annoying, man. But I think I'm pretty sure that if I've solved these, I'm pretty much gonna be able to solve any questions. The harder questions is something that I need to get used to, though. Anyways, sorry. So, I get it that you need to have a some sort of like target, and then this iteration is what is important. Exit condition is very easy. Like as soon as you have nothing left to add to sum, you can just exit. Now for index, add length of candidates if the difference of amount left and the candidates is greater than 0. Right? Like if it's, what does it mean if it's less than 0? It means that it's negative. It means that your adding, you're overflowing your target. You're going beyond your target, which is not what you want, right? You want to be always beyond, below your target, and otherwise you want to exactly hit your target. So if it's below your target, you're doing this, and the effect that it is having is you go to zero, right? You go to zero, and you you keep adding two, right? You keep adding all twos and see if you are reaching this. You pop two. You don't even need to pop shit. You don't even need to pop shit. You added two, then you came back. You added all twos except two. You added three. You added all twos except three. You added all twos, then three, then two again. Something of that sort you did. Ah, I see. If you did not have this index, you would have been forced to add two again, but instead you're just gonna do threes all the time rather than sixes all the time. So that's the reasoning behind this IDX loop. Okay, I get it. Time to commit this to memory and like get our muscle memory back in shape. So we're gonna do back IDX. Like you need like T left or target left, and you need like a path. I'm gonna be like past this for now. I'm gonna be like back of zero. You need the entire target, and you have nothing right now, and you return answer. That's the thing that you wanna do now. Now. I'm gonna be like L equals len of candidates, right? I'm gonna be like non-local of answer and L, right? Now what I'm gonna do is if target left equal 0, right? There's nothing left in the target, then I'm like answer dot append path. Cool. Now you do a return. You're done with this part, right? Now for I in range idx, right? Len, okay, L, if target left minus candidates of I is greater than equal to 0, then you do something, right? Then you do a back of I plus 1, right? Target left minus candidates of I, and then you do path dot append, okay, path plus candidates of I, right? This is what you gotta do. And if I run this, what the sigma, bro? Okay. Oh, okay. I just not gonna do like copy, because since this is getting recursively called, it's gonna be, what the fuck, bro? Hold on. So it's getting this, right? This is gonna be how it works. Answer to depend path dot copy. Path is where I'm, okay, so let's see. This should make sense, bro. Comparators, am I fucking up in the comparators again? If target left is 0, let's just do a hand run. It comes in 2, right? This is not done, so target index से लेके L तक जो कि 0 था, my target left was पूरा target 7 का 7 बचा था, and can target 7 का 7 minus candidates of I जो कि 2 था, greater than 0 है भाई. तो मैंने बोला अंदर ये I plus 1 डाल दो, target left मतलब 7 minus 2 कर दो, and path equals candidates of I कर दो. So I'm just gonna be like print of path. Just wondering where it went wrong, right? Somewhere is fucking up. Somewhere it's acting funny, macha. So it did 2. It did 2, 3. So it was empty first. Okay, the third is path, right? So it did 2. So okay. IDX target left and okay, path we got already. So just curious, man. Let's see. So it first came to 0 and 7. That's fine. Then 1 and 5, which is fine. Is this causing the issue? Is it that I'm saying कि तू आगे बढ़ जा? Oh, I get it now. I get it now. My bad, bro. My bad, bro. I was doing back +1, and the reason I was forgetting कि I'm having a loop here, and I was saying कि इसके अंदर तू भाग भेज दे, ठीक है? I get it now. Can't be doing that bitch ass हो shit. Cool. So it's 99.60% से ज़्यादा fast है. We just built that way, bro. We just built different. Okay, anyways. हगा तो बहुत हूँ मैं इसमें. हगा तो बहुत ज़्यादा हूँ. But ठीक है. So let's do combination 2, right? Let's combination 2 में क्या है? Maybe use once in the combination. Maybe use once in the combination. So 116 है. Each number in candidates can be used once in the combination. So you know what I can do is I can try to use that strategy of that we had seen in the subsets too, right? So I can do answer equals this, L equals len of candidates, right? Candidates dot sort I can do, because why not, right? Like a man's gotta sort shit out, bro. Like that's a man's way. I can just do def back, I can do index, I can do target left, then I can do a path, I can do like non-local answer and L pass back of 0. I'm just I don't know, like trying to see if I can do it that way, but I'm not sure if I will be able to. Return answer is what I gotta return, right? Here's the thing. If target left equals 0, right? If target left is equals 0, I will just say answer dot append part dot copy, and I'll say return. Cool. Now for I in range IDX and L, if if candidates of, or maybe if target left minus candidates of I less than equal to target left minus candidates of I is less than or equal to 0. Sorry, yeah, less than equal to 0. If IDX not equal to I and candidates of I equals candidates of I minus 1, continue, right? I can take this outside over here, I guess. I can just do like back of I, yeah, this bitch, and path plus, I guess, candidates of I, right? So I'm thinking this could work. So the only thing that I've done is I've just added this one and the sorting thing. And the rationale behind this is that if I sort this out and if I do this, it's always gonna be going here. If this is just usual, right? It's just gonna be like you're allowed to use one of the combinations. You're allowed to use the combinations once, I believe, right? So it's still gonna allow you to do that, right? I'm thinking this might not work. Memory limit exceeded. What the fuck, bro? What the fuck does that mean, bro? Okay, hold on. Let's see. I am pretty sure I must have solved it somehow. Edit candidates are short. I did this. T left is less than 0, you return. That's fine. That's fine. Interesting solution. This should be equivalent though. Like if it's negative, I don't even want to make the call, right? So it's fine. Oh, but I'm doing I plus 1. Interesting. This time I'm doing I plus 1. So interesting. Did I fuck up the comparators again? Target left minus candidates of I. अगर नेगेटिव हो गए I think I fucked up the comparators yet again. Yeah. Ugh, I need to keep that in fucking mind, man. I'm just gonna write this down on a piece of paper that I keep fucking up the comparators because I do be doing that shit, right? So I'm just gonna go to like one of my notepads and y'all ain't gonna be seeing that shit, bro. But let's just do MSCS. Maybe I'm just gonna do job prep reflection. So lead code, I've gotta be careful with arithmetic comparisons, especially in binary search. These are the errors. Lead code, most common errors is what I'm gonna write down. So I've got to be careful with arithmetic comparison, especially in binary search, subsets, combinations, etc. Memorize those patterns, brother. Cool. That's one. Cool. I've written it down now. So gonna have to keep So fine. We were able to do combinations, which is pretty straightforward, I guess. Let's do permutations. Permutations. Maybe anyone got some permutations to solve, I guess. Right, baby girl, right. Have I solved letter combinations ever? I think I have. I've solved almost all of these shiz. Bro, I know I solved all of these things. I'm kind of like pro. I don't think I've solved n queens because this one's like a hard one. Ugh, I should be able to solve n queens also. It's like the classic fucking lead code problem. What? N queens is not in 75? What the frick? What the sigma, bro? What does need code all like? What does need code all have? Doesn't need code all just have 580? What the fuck is 580, bro? Oh, JavaScript. I ain't doing JavaScript shit, bro. Sliding window is fine. Why do they have so many here? Who's gonna do this shit, bro? No motherfucker is gonna do all these questions, bro. Motherfucker, bro. Motherfucker. Okay, let's do permutations real quick. Right, so permutations is 1 2 3 1 3 2 2 1 3 3 3 2 3 1 3 1 2 3 2 1. Permutations is actually a very easy one. I know that this one uses a very peculiar technique, I guess, in some sort of way. I know it's just like two calls and then something else. It's just something. Okay, I'm just gonna go through the submissions because I don't wanna waste time on something that I've already done a bunch of times before. So I do it with like a back. This is like the standard thing, and it's like a visited thing. If the length of the path is equal to the length of my numbers, which makes sense. And for I in numbers, oh, if I have visited it, oh my god, dude. If I is not in visited, you add it to visited, you do backtracking, you add that number and you say visited dot remove again. Oh, beautiful. That's all you do. Okay, let's try to see why this was happening in the first place. And then I'll go and do some sort of like and like I see another student across the like right from my window. I have a view of another student apartment, and then there's this dude who's just always sleeping, man. Like I see he comes, pulls the blanket, and he just fucking goes to sleep, man. I've never seen that motherfucker. It's like fucking 5 p.m. and that dude is fucking sleeping. And I'm like, okay, bro, I feel you, baby girl. But anyways, enough tomfoolery. Enough tomfoolery. You just gotta keep working hard. You just gotta keep working, bro. Fuck, my ass hurts just by sitting here for so long. But let's see. Did I have different solutions? No, I had the same ones, right? So, this makes sense. And if you visited a number, right? You first visit 1, you first visit 2, then visit 3, and then you come back. The call for 3 is done. You pop 3. 3 is no longer visited, right? And it's going from I for all numbers. It's not just going for the first number, it's just going through all numbers. So it did 1, it did 2, it did 3. For 3, it couldn't do anything else because everything was added. It went back, it just did a remove of this. It went back, it removed 2, but it added 3 back, and it then added 2 back, and it removed 3 again, it removed 2 again, it removed 1 again, it added 2, it added 1, it added 3. I see now. Let's close this motherfucker and let's try to solve this ourselves. Answer is this, right? Def of back, it's gotta be like an index, and not even index, you just need a path. You pass, you do a back of empty, you return an answer, right? Now what you gotta do, if len of path equals len of answer, right? You do answer dot append path dot copy, maybe. Let's see. Yeah, this makes kind of sense. Making kind of sense, bro. Now for I in range len of nums, right? You know what? L equals len of nums. I think it's gonna be constant. I don't think. Oh, come on, shut up, bro. Sorry, my bad. It's gonna be L. I just don't want it to like keep computing L all the time. Maybe it doesn't need to, but anyways, just being paranoid. Of course, you need like a visited thing, right? Visited equals set, and like visited, right? And if I not in visited dot add numsify, then you do back of path plus numsify visited dot pop numsify. I don't know if it's like pop or remove. I think it should be remove, maybe, right? Maybe it's just this. I don't know. Oops. Oh my fucking god, why did I put parentheses there, dude? Like, I'm fucking having a brain fart. I should probably take some break. I should do some sort of. Why is memory limit exceeding, motherfuckers? What the fuck? Is it just this thing that I'm doing? Maybe, I don't know. Something's obviously wrong here. Why is the memory limit exceeding, bro? Like, fucking come here, no? See. Oh, fucking idiot. Fucking. Oh my god, dude, I get it now. This was such a embarrassing run because. Oh my fucking god, dude. I made 3-4 mistakes. One is I didn't do a return here. Right, this was one mistake that I did. Mistake 1, did not put a return here. Oh, and okay, so if I ever get a memory exceeded, I know what the issue is. Results in memory exceeded issue, right? There's nums of I. This is fine. Remove is fine. Okay. Added the number rather than the index. Should have realized that adding number is bad because array can have duplicates, right? Should have, man. I fucking. But anyways, let's just add this to notes. In backtracking problems, remember to add a return statement once you are done with the question. Okay, once you're done with the exit condition, else you get memory limit exceeded. Error. Next, what do we have? Fucking hell, bro. Need to work harder than this. Oh my god, dude, people are fucking having sex right now. Motherfuckers, man. People should at least close their windows, man. Anyways. My bad, bro. My bad, bro. Okay, so what was the other error that I made? Okay. When adding things to set, be cognizant of adding index versus the num index to set. Arrays can have duplicate values. Okay, context is permutations problem. Cool. So just made a note of that I can't be fucking this up real bad. Anyways, so let's go to backtracking. Wait, what? Yeah, sorry. So permutations is done. I know that I've done word search, palindrome, and these two, but I just need to like check them off, I guess, at some point. I don't want to like check them off prematurely because I want to deliberately solve these questions myself. You know me, you know how I am, boy. Cool. So these are done. Tries. I've never done a single try question. Fucking annoying. I've never done an advanced class question also, which is kind of sad, I guess. Greedy questions. I've not done a greedy question also in ages. I know jump game. I know there's this. I need to do all these greedy questions honestly. I know I just gotta. Does Neat Code all have videos for his? He has videos for everything. Good. Oh, so he's essentially adding videos for whatever questions he's solving. That kind of is neat, I guess. Kind of is neat, bro. So, anyways, I don't need a roadmap thing. Cool. So what we'll do is just gonna do fucking hell, bro. No, 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 motherfucker. Need to edit this shit. Anyways, there's nothing. I don't think that shows up though. Does it? Cannot. Fuck it. Let's just see. No. Let's just see if I do open right. It does fucking show up. Do I have anything sensitive? I don't. Thankfully, I don't. It's just hemophilia documents, but that's just the condition that I have, and that's okay. Like people should learn about hemophilia. Let's actually, like fuck it. Like if people are watching this, might as well educate them about hemophilia. Hemophilia, right? Okay. So it's a rare. Oh fuck, brain farts. It's a rare genetic blood disorder that happens when your blood doesn't clot and make your bleeding slow down or stop. So one of the interesting ways in which it affects me is uh, every time you're walking or moving around or doing anything, right? You will have a lot of wear and tear in your joints, and you will also be healing at the same rate. So you will be hurting yourself, but you'll also be healing. That's essentially the idea behind it. uh, Having said that, right, having said that, the only issue that occurs is for a person like me who has hemophilia. uh, when my blood doesn't clot, my joints continuously they start wearing down. Like there's a lot of internal bleeding, and then the joints swell up, and as a consequence, I lose my ability to like move properly. I lose my ability to walk. I have to move on crutches. If I have elbow bleeds, I can't even use crutches. I have to use wheelchairs, and I have to rely on someone to move my wheelchair. If it's like a normal wheelchair, if it's like an electronic wheelchair, sure, I could just use some buttons and shit to move around. But yeah, that's how it works. And if I can like show, I think some images. Okay, like maybe knee bleed. So boom, this is kind of nasty, but this is how like a knee bleed looks like. This is the swollen knee. Let's see. Yeah, this is again another example. So these are just this is bleeding. This is just internal bleeding. Okay, hold on. This one has a good picture. There's a picture here of, yeah. This one, dude. This is essentially how your knee can look if you have hemophilia. This is how. Oh, look at this one. Look at this one. This is how your knees look if you have a severe joint bleed. It's the most fucking painful thing that I've ever experienced. You get, yeah, you see this, you get these randomly, and this guy has had like knee replacement done, I believe. And let's see some more messed up pictures. There's of course elbow bleeds. This guy has an elbow bleed, which is equally bad honestly. But yeah, this is the thing that I have. Like I have knee bleeds. So this is essentially how the knee bleeds look. Oh my fucking god, this is painful. I remember going through this as a kid, and back in India, most of hemophilia patients go largely unmedicated, right? Uh, they do not have, they cannot afford the meds. Like the meds that I'm on, they are extremely expensive. Like if I'm back in India, I can definitely not afford. If I'm here, if I have insurance, maybe I can afford them. If I'm off insurance, I'm kind of like again a cripple. So for the first 15, 16 years of my life, I was on a wheelchair and like constantly on crutches. I essentially could not walk. And one of the consequences of hemophilia is essentially when you have a leg like this, like when you have a leg like this, one of the leg will be like super well developed, but the other leg would be like completely skinny and there would be no muscle. There'd just be like, for imagine for like over a decade you're not able to use one leg, right? So one of the things that also happens is a lot of these joints become very stiff. Patients are unable to move their they're unable to move their joints, or they lose mobility, they lose range and so on, and there's just immense muscle wasting that happens. So that's what happens in case of hemophilia. It's again kind of painful, pretty fucked up. I think this is one more dude. This is the most fucking accurate image ever. You will see that this one leg is so well developed, but this one leg is so thin. That's what you will see in hemophiliacs. Like they will have one target joint which will be like extremely prone to bleeding episodes, and for prolonged, they essentially can't use this one, right? That's the idea. They essentially cannot use this leg for years and years. And for me, it was the right knee. I could not use the right knee, and I had to just rely on wheelchairs and crutches for like almost. Yeah, this is also another really good example of like muscle wasting. Like this one looks like a pretty decent leg, but this one, like you will see, pretty thin, no calves. But this one's like probably the best example. I think probably I'll just like bookmark this because this is something to show people. I have my own leg that I can show to people, but it's like a really good uh, research on muscle wasting. Okay, cool. So I just saved that. Oh yeah, so this is I think they're talking about this. No, I don't know what this is. Wasting atrophy. Okay, okay. Yeah, I think there's like something here. Yeah, severe muscular atrophy. Yeah, I mean that's just how it is. Yeah, you okay? Let's see if this image can be opened. Oh, you will see this. Like the legs are bent in the wrong direction. There's a lot of atrophy. Oh, this guy probably has like ankle bleeds. This could be like his target joint, but they become stiff and they get bent in the wrong ways and so on. Again, it's a ugly condition. It's probably the most painful thing that you have to go through. I'll tell you something else while we're on this topic. Yeah, when you keep your leg like this, right? Even if you move it like a centimeter to the left, centimeter to the right, it causes immense pain. So you have to have these like pillows under your leg, and yeah, I mean the pain is like unbearable. Like I've probably gone nights without sleeping. It's just insanely painful, and I've like dealt with that pain for like I don't know, like 16 years or so. It's kind of messed up, but that's just how life is, I guess. Like you just gotta be like, you just gotta deal with these things. Again, this is how hemophilia works. That's why I had these documents, and I'm kind of happy. Okay, so here's the thing, right? Hemophilia care India. India is like a good place. I come from India, but the problem is there's very little treatment. There's some subsidized or free things, that you can do in India. Like you can get some meds in India, but they're also not very easily available, right? So that's kind of sad. All the good meds are available in the United States in like under insurance, so that's kind of pretty nice. But okay, that's pretty cool. That's pretty cool. Anyways. Yeah, it's not just, it doesn't just affect joints, but it just affects a lot of things. Like if you have random ass joint. Okay, sorry. So if you have random ass, if you had a issue with your teeth, for example, like if one of your uh, tooths, whatever, fell out, even that is very painful to deal with. Uh, yeah, let's just some lore. Let's just spend like 15 more minutes doing a break and then we'll get back to studying. Gonna go grab a banana. BRB. BRB. Ah, fucking hell, bro. Okay, we're back with a banana. We're back, baby. I just need a baby. I see you do no wrong. Okay, hold on. I'm gonna be back in one more second. Maybe 10 more seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, baby girl. Cool, I'm back. So, let's see. I want to do a few more. I want to waste my time for a little more time. Okay, so I'm just gonna be like this. Okay. Shit, fuck. God, मैं क्या कर रहा हूँ भैंचोद? I forgot that I had live stream on and I was just chatting with random people. Anyways, my bad, my bad. Uh, okay, okay, okay. Let's see. Let's see. I want to chill for the rest of my life. I don't want to fucking work and conform to societal standards. Life is dash. I'm just so tired. Something. Okay, cool. Heroin or addict Ronnie. Okay, you know what? I'm just gonna browse Hacker News for a while. If YouTube had actual channels, what the frick, bro? No, hell no. Inside the 3 billion people national public data breach, crazy. How I won 2.7k using JavaScript, yeah, and a can of W. Nah, I'm not interested in learning about that. Dune scientists observe first neutrinos with prototype detector at Fermi Lab. Is that a good thing? On this experiment 10 years ago, macha, what the heck, bro? Okay, bro, crazy, bro. This is crazy, bro. Okay. Okay, anyways, ये कौन है बे? हिलरी? हिलरी यार, क्रेजी मैन, लाइक ये गोरे लोगों का नाम हिलारी क्यों है? Fucking crazy, bro. Like I mean, I don't know, man. Like हिलारी, वो हिलारी भाई, क्रेजी भाई. मतलब it's just nah, man. I mean, I don't know. Like the Gora people probably don't know this, but I don't know. Okay, there's nothing here even in. Oh wait, what? Sponsor block. Skip sponsor segments on YouTube. Crazy. Ajay.app. There are currently these many users who have submitted skip segments, which have a total of and an open API for skipping sponsor segments in YouTube videos. You submit when a sponsor happens from extensions. Ah, this is beautiful, to be honest, bro. Let's see Ajay, what Ajay does. Not this, bro. Home. No, I want to. Yeah, let's see Ajay that app, right? Okay, crowdsource. Ottawa created Java grants. Pretty cool, man. I love this kid. Guessing he's a kid. Anyways, let's reload this and see what else is there. The darkest isekai manga ever made. I've seen so many of these things. Don't trust it anymore. Okay. Okay, not this. There is interview with the creator of LLVM. Yeah, I love Chris Latner, man. He's a legend. Is that Chris Latner? Let's see. Yep, that should be him. Yeah, that's him. Creator of LLVM. That's so cool, man. Chainsaw Man just changed everything in that, right, bro? The skin suitcase. Gotta watch this, bro. Business advice from a billionaire. Whatever, bro. Anyways. Fucking. Okay. You know what? One more thing I'm gonna try. Not this. Maybe this one. Maybe I could do this one. Okay, so I'm just gonna go here. Let's see. Let's explore a little bit. A web browser that plays old world blues to build new world hope. What the Sigma? What the Sigma, bro? Nah, not interesting. But it's written in Rust, which is interesting. So I'm just curious what framework is he using. Web app. Oh, it's okay. Web browser. Crazy, bro. How do you do that? Wow, that's crazy, bro. Okay, Grafana, I know. AI Toolkit, I know. I don't know AI Toolkit, sorry. The official conference of Droid Kaigi, whatever. Deep Life Cam. Oh, this is pretty cool. Could use in whatever. Tailwind. PG Lite is lightweight Postgres packed as a WASM into a TypeScript library for the browser. What? What the heck? Wait, what are you saying, bro? Are you saying that you can run it in? Crazy, bro. Oh, this is such a cool one, man. Interesting. Let's see. Sweet list. This is such a stupid Okay, this is good. I like this one. I want new grad positions. I don't want this. That's pretty good, I guess. Pretty good. Pretty good. Gotta start it. Because I can just like go one by one and I apply to all of these. Right. Whenever the time is right. Interesting thing about this is could parse this. Oh. Oh, okay, okay. I see. I like it. Okay. Oh, so locked is okay. I get it. I like it. So this date is posted on 13. Pretty good. Pretty good. Pretty good, man. You know what, bro? Cool. Let's see. Should we list grad? Why the fuck would you create a turbo and lab like this, right? Oh, daily, honestly. Yep. Pretty good find. Pretty good find. I like it. Replace OpenAI GPT with another LLM. Fuck this. Alright, little bro. Okay. Okay. I'm just gonna check a few emails, I guess. Okay, I guess.